Okay, I think we can start. We are like 2 minutes after the schedule, but I think it's okay. Good morning, everyone. I hope you're having good time at the conference and in the Barcelona in general. And to be fair, Barcelona is such a nice place that it's difficult to not have a good time here. I spoke recently with my colleague that I will give this talk about Java relational persistence, and he told me like, oh my God, why can't you tell about something that is actually cool, modern, like, you know, maybe NoSQL, microservices, and so on. So maybe let's follow his way of thinking a little bit. More or less 10 years ago, like 10 years ago, the NoSQL movement started. And there was a first NoSQL meetup in San Francisco, and more or less like everything starts in San Francisco, so we can put it like a pretty good date. And I'm wondering how many of you work in the business like professionally for more than 10 years? If you could raise your hand, just it will be. Okay, I think it's like more or less 50-50, like 50%. I find it quite interesting because when I started working and I was at my first conference in 2008, at that time, when someone had like 3 years of experience, he was already qualifying to be a senior because the whole community was quite some immature. But back to the meetup. So the meetup was announcing the end of RDBMS era, maybe, right? And one of the quotes from this meetup was that the relational databases give you just too much. They force you to twist your object data to fit into RDBMS, and NoSQL just give you what you need. And I think everyone who worked with relational databases or, especially with document, let's say, based databases kind of know what it means. And the two main problems that people were seeing with relational databases was that they were not really scalable, and then they were inflexible, meaning we had to define this fixed schema. The schema was really hard to change, and these were like the two main concerns that NoSQL databases were addressing at that time. And it was 10 years ago, so it was already quite a while. But a lot of things have changed since then in the relational database space. And I will just picked like 3 databases, or maybe even 2.5, that are the most popular ones, that they are open source. I didn't work too much with Oracle, so I will not say too much about Oracle in general. But the Postgres, especially, that's my favorite database. Over the last years, they really developed a lot of improvements in the let's say the core engine. So back in the days, whenever you wanted to make a change in the database structure, like adding a new column, changing the types, and so on, it was very likely that you would end up in the table lock, meaning that your database will not be able to either read or write from the particular table or particular row. It really depends. And of course, for the applications that we often build nowadays that have like millions of consumers, thousands of requests per second, like having this table lock, meaning that the requests will start piling up and basically everything will start to explode. And that's the problem that they almost eliminated. So nowadays it's quite unlikely that you will get a table lock. Even when you create an index, you can create the index concurrently so that the index is being created in the background. They also introduced the JSON data types that directly addresses the, let's say, the NoSQL database's advantages. So now, not only you have all the benefits of having the relational structure, but also if you need to store some sort of unstructured data, you can put it into the JSON column type, and you don't have to put it just as a string. This is actually the structure that you can both index and you can query like using the fields. They also have a support for XML that I haven't personally used. They also support geospatial queries and full text search. The full text search maybe is not as impressive as the Lucene index and let's say the Elasticsearch, but still, it's totally sufficient for many use cases. So Postgres basically became a really, really serious feature-rich database. MySQL back in the days was considered let's say the database for WordPress, so not for serious stuff, but over the years they also evolved. So now they have the features that we expect to be a standard, that they have foreign keys, AC transactions. They also support JSON, and it's used in lots of serious projects. So Pinterest is based on MySQL, or at least it used to be. And then we have these were the 2 databases, and now we have the half, because AWS Aurora is not exactly let's say the completely different database, but it's rather an engine that it's built on the, or maybe it's a database that it stays compatible with either Postgres or MySQL, and they advertise it as the relational database for the cloud. And all the other cloud providers have something similar that I haven't worked with, but AWS Aurora addresses very nicely the scalability issues of relational databases. I mean, one thing is that they claim at least that it's much, much faster, like 10 times faster than MySQL. The benchmarks show different things, but it all depends how you manipulate the benchmark. But there are two nice ways to scale the Aurora database. And one is you can scale it up, so basically you can use the bigger instance, which is nothing really new. But considering that you can scale it up to the machine that runs on 120 CPUs and 4 terabytes of RAM, I mean, you have to admit that this is a pretty nice node. I mean, this is something that can handle quite a lot. But you can also scale it out. So you can put more read replicas, and that means that all the reads go to read replicas, and you can have like as many of them as you want. Probably there is a limit. So for many use cases, that's also sufficient, and they also introduce the serverless version, meaning that let's say the assigned compute power, including your bill, like it scales depending on your traffic. So these were the two issues that were the main problem with relational databases, and they have been kind of addressed until now. But for me, the most interesting and the biggest problem of NoSQL databases is that, or maybe the benefit of relational databases, is that the relational databases are much more forgiving. If you use NoSQL databases, and just to clarify that, I'm a big fan of NoSQL databases, in general, multiple different databases. But they come with a significant drawback. So usually when you work with NoSQL databases, you have to structure, you have to design this implicit schema for the particular use case, or the particular feature for particular access patterns. And what may happen is that the requirements change over the time, or the access patterns change. And then you suddenly may end up in the state when your NoSQL structure does not fit anymore. And then you have to restructure it. But restructuring the NoSQL database is not an easy job, because there is just no support for it. So usually you have to either script it or find another workarounds. In the worst case scenario, you may be even not able to restructure it because you may be lost already some data. But with the relational databases, we have all the power of SQL. So whenever something changes, we can very easily, using SQL language, having the guarantees of SQL language, we can basically restructure the data, reshuffle it to different tables. So I very like a lot this tweet from Lucas Eder, that I mean, SQL is not going anywhere. Relational databases are not going anywhere. They were valid for the last 20 years, and I'm pretty sure they will be valid for next 20 years. My name is Maciej Walkowiak. I'm an independent consultant, meaning I work as a freelancer, working with Spring using Spring technologies since 2007, and Java recently. Most of the projects I work with are based on Kotlin, and most of them run on AWS. I also contribute to open source projects, and these are usually the Spring projects. This is like one of the recent changes that I did. It's not maybe extremely impressive, but whenever I find something that I find a bug or something that maybe could be improved, then at least I try. And it doesn't happen very often, but I encourage you to do so whenever you have time. For last year, I spent most of the time with my son. I took the 6 months parental leave, and I know that many people cannot really afford it, but only if you are, I would strongly encourage you to do so, because this really builds the bonds with children a lot. I also run a YouTube channel called Spring Academy, where I post videos, tutorials about Spring. The videos are released more or less once a month, or when it goes good, because it's quite time consuming. But if you are into Spring and you enjoy, let's say, watching Josh Long Spring tips, this is something that we can say that it's, let's say, similar, or it's aiming to be as good as Spring Tips. But back to our topic. So the topic of the talk is the state of the relational databases. Sorry, the state of the Java relational persistence. And there is a lot of things going on in this space. There are lots of interesting frameworks, lots of interesting technologies. And the idea is that I will introduce these technologies to you so that later on, if you like either start a new project or even work with your existing project, you will be able to make better decisions like which technologies to choose from. But before we do, I would like to clarify some basics because I saw the discussion on Twitter between two Java champions, like if Hibernate is an alternative to JDBC, so like a very quick introduction how these things actually work. So it always starts with a database. It doesn't really matter which database it is. And on the other side, there is our application. The application talks to the database over network. And each of these databases use a little bit different wired protocol. So we, of course, don't want to learn like or go so low level. We want to write SQL queries. And in order to do it, it goes all through the JDBC drivers. So the JDBC is a standard. There's like set of interfaces that each of these providers on the right-hand side have to implement to be compliant with JDBC. So then we take this jar into our applications and we write the code that looks something like this. This is not exactly the code that we write. At least I haven't seen this kind of code in production because obviously this is way, way too low level. I mean, you don't want, I mean, it asks for making bugs, right? But there's nothing wrong about the JDBC itself. What we usually do is we think in objects, right? Java is an object-oriented language. We are very used to work with entities, and this is more or less the code that we want to write. So we put in our application JPA provider, which in most cases is Hibernate. Anybody uses different JPA provider here? There are 2 hands. Okay, so it means that it's, I don't know, 5%, maybe something like that. I personally never had a chance. I'm not saying that Hibernate is the best, but it just became such a standard, right? So it works in a way that there is a Hibernate inside our application. There's also the JDBC driver, and whenever we do something with the Hibernate, it always goes through the JDBC. So JDBC is still working under the hood even when you use Hibernate. So for the rest of the talk, I will actually use JPA and Hibernate, and I think always about the same thing. And I would like to start with JPA. So JPA, most of the people, whenever a project starts, there is a relational database, they just take JPA. This is a standard, everyone knows it, and it's simple, right? At least it's easy to start with. And I don't think actually that JPA is simple. I think that JPA is super complex. If we look at such a mapping, this is like the canonical example more or less. We have these 3 entities and we would like to persist them into the database using JPA and Hibernate. So the first things that we do, we put these annotations like an entity, the ID, one-to-many, an order has multiple order items, an order item relates to a product. So this is already bad because the order is a reserved keyword, so we have to put the at table, but this is actually not a really big deal. But I had to run it first actually to find it out. So then we write the code with most likely Spring Data JPA that looks more or less like this, and we expect it to work flawlessly. But what actually happens is that we get this exception, transient object exception, that the object references the unsafe transient instance. And for someone who is, let's say, at the junior level, this is very kind of cryptic message, like what does it mean? Of course, I mean, you have to learn JPA to really understand it, but you have to put the cascade type all, and then the code works well. Except the database structure that it creates is not something that I would at least expect. Because between the order and order item, we have a one-to-many relation, but the database structure that is generated or what Hibernate expects is different. So how we can fix it, we have to put another annotation that is a join column, and then we will get the database structure that we actually expect. And there are many people that struggle with these kind of problems. And every time you have this kind of problem, you have to run the application to run the test to see how it actually works. And this is just a simple example. You could go actually much deeper with all these little things in Hibernate that make a big difference. So how do most of the people usually handle this issue? They go to Vlad's blog. And Vlad he used to work as a Hibernate developer advocate, and he's basically the guy who knows everything about the Hibernate. So everyone goes to his blog post, and it's not a big surprise that he has hundreds of thousands of visitors per month, because his content is actually very, very good, and he addresses the real problems people have. And I'm not even saying only, let's say, junior developers' problems. Like normal people who work in the business for years have these issues, including me, because I tend to forget this kind of stuff. So he basically explains everything, like how you should do things with Hibernate, how to make this works like good from the performance point of view. And I was like wondering, it would be actually nice something to have something like Ask Vlad as a service. This would be the best. So that then I actually don't have to go to his blog whenever I find an issue, that just somehow works for me. And Vlad developed recently a tool called Hyperpersistence Optimizer, which is not free, but it's also inexpensive. And I think especially if you work in a bigger company that has a bigger budget, this is a tool that is maybe worth considering. So Hibernate's Hyperpersistence Optimizer is a tool that meant to work like as Vlad as a service. So basically you have your code, you ask Vlad, and it tells you what is wrong. And the usage of it is very simple. So you add just one dependency to your project. I think it's still in the snapshot, I don't know. And you put this test class. This test class, I didn't even go deep what it's actually doing. It's just copy-pasted from like the guide, how you should use it. And it introspects all your mappings and JDBC configurations. And as an output, you get something like that. So this is what I run this code against some of my classes. So it immediately gives you the hints, what did you mess up in your Hibernate configuration? Some of them you can maybe agree. In my case, they were both critical. That was kind of a surprise. But yes, so this is something definitely worth considering. At least there is a trial version, so you can always try it out. But if we go back to this design, to these entities that we have that, let's say, now are correct according to JPA and Hibernate, there are still lots of questions that remain unanswered. So which entity should have corresponding repository? Should order item have a reference to product? And should order item have a reference to order? I mean, there are multiple ways how you can structure it with JPA and Hibernate, and it doesn't really tell you how to do it right. It leaves it up to you. And most of these questions were already answered in this book, or in general by domain-driven design. They tell you how to structure the project, and with this knowledge, probably you can go quite far. And this is how we transition to the Spring Data project in general. So Spring Data is a project that is built with domain-driven design in mind. So obviously you have the repositories, you have your entities. I think everyone knows more or less how it works because it has become a standard. And I was looking like, what is the oldest note about Spring Data project? And I couldn't find anything about the version, let's say there was a blog post about 1.0, but actually the Spring Data JPA has grown out of the project called Hades, developed by Oliver Droptbon, something like that. I hope I didn't misspell it. And the Hades was like the project before the Spring Data JPA, and it was based on the idea provided by Eberhard Wolf in the magazine, in the article. And this later on it transitioned into Spring Data JPA and Spring Data in general. I find it very fascinating that the library that basically changed everything related to relational persistence, how we write applications, and basically how our applications also affect the world, is a result of the article written that could be also a blog post. So if you have some ideas, I would strongly encourage to write a blog post, because you never know how it may end up. And the one feature about the Spring Data that I would like to speak about is something that is not very well known, and I think it's a little bit underused because there are many nice use cases for it. And this is about publishing domain events from aggregates roots. Let's consider the following code. We have an order, and the order can be confirmed. So this is like the very typical business method for confirming the order. This is how usually it starts, but later on we've got another requirement that whenever order is confirmed, we have to notify the customer that the order was confirmed. Then later on it goes another thing that maybe push notifications have to be sent, and so on. So basically, this method is a perfect candidate for ever-growing method. And we, at some point, may start to lose what is the actual domain logic here and what are just the separate different concerns. And there is a way to address it. With Spring, we can use the Spring built-in event bus. So we can inject the application event publisher, and then whenever this thing happens, we just publish a new event that the order is confirmed. And the order confirmed is just a very simple class with whatever fields we need. In this case, it's just an ID. And then we have decoupled this whole sending email, pushing notifications, and whatever other concerns are there into separate components that just listen for these events. This is already looking good, but Spring Data gives us options to make it even better. So instead of publishing this event in the method itself, we can make an order as a class that extends abstract aggregate root. And abstract aggregate root gives us an option to register events. So whenever something happens inside the aggregate, we can register event that something like this happened. So everything stays like changing the state, including publishing the events, it stays inside the aggregate. And what happens then, instead of having this event publisher publish event, we can just save the method, and Spring Data under the hood, whenever the aggregate is saved, it emits all the events that were registered before. So we basically ended up with a method that looks exactly like the beginning, with all of these nice features. And in my opinion, this looks really good, and the separation of concerns is something that it's worth looking at. So let's look at another example. It's a little bit trivialized, but it's just to get to the point. So this is a very typical use case when you're working with relational databases, that we not just have a CRUD where we fetch the data, save the data, and so on, but we have to perform some either aggregations or reporting. For example, to build such a nice HTML table in the end. And a very naive way to do it with Hibernate and JPA is to just you have an order, so why not just to have a method that returns these quantities, since all the order items are already there. This method looks perfectly fine from the object-oriented point of view. So if you write something like this in your object-oriented classes in university, probably you would pass. But what happens under the hood is a little bit scary. So then if we execute something like this, one query is to fetch the order, and then for each order item there is an executed separate query under the hood. While if we would do it just with a SQL, it will be as simple as that. That's like the SQL 101. So the lesson that comes from it is that Hibernate and JPA is a not alternative to SQL. Whenever you use Hibernate and JPA, which are great tools, don't forget that SQL is still the tool that you could use and probably should use. But then the question is, how do we execute native SQL when we use JPA and Hibernate? And one of the ways to do it is to put something like this on the entity, like to create a native query. And I think this is something you, like a sane person, or not sane, I mean, the average person like me cannot really memorize. So I would have to Google it all the time. I mean, this annotation tree is not very tempting, at least. But fortunately, we have Spring Data, so we can do it in a much, much nicer way, right? So every Spring Data method, we all know that we can Spring Data JPA. I mean, we know that we can put the query annotation where we can write the JPQL query, but there's also this one property, native query true, that lets us execute native SQL. And this looks already much better. And this is I believe, the default way to actually executing simple queries when you use Spring Data JPA. The problem really starts when we have to build something more sophisticated. When we have let's say we build a search engine and we have multiple criteria to choose from. This is the property search in Spain called Fotocasa. You can choose different prices, different criteria, or how you want to pick your flat. And building it with SQL is also quite challenging. So I took here only the subset of the price. So here we want to select the flats that fit into particular price. Part of this code is almost duplicated. So at the beginning, we have to build a SQL query. At the end, we have to set the parameters to not have any SQL injections. And this code is very, very error prone, because when we build the SQL queries manually, it means that we are vulnerable to any type of silly mistakes. So we can forget the comma, we can put the space, or we can forget the space, we can put extra comma. Basically, string concatenation is not the greatest way to build SQL queries. And this is that we come to the tool that it's called jOOQ. Yes. So jOOQ is not a new framework, but also it's not as popular as Hibernate. jOOQ is a tool developed by Lucas Eder, and Lucas Eder is the most popular and maybe even the most knowledgeable person on the edge of Java and SQL in the world. So basically, he developed this tool himself, and it seems like he knows everything about SQL. And he developed a tool called jOOQ, and the jOOQ, it's the mission statement is quite clear. It generates the Java code from the database to build fluent, compile time-friendly, let's say, SQL queries. Thing to note is that jOOQ is not an ORM, so it's not meant to compete with JPA or Hibernate. It's also not a Spring Data project. It is just a library to build type-safe SQL queries. And it's fantastic when you have to build complex queries to database. So it's fantastic for reading the data. It may not be that great if you want to save the data. So of course there is a possibility to save the data, but from my experience working with ORMs, when you have to fetch the data, change it, modify the state, and persist it, is often much easier with just JPA or Hibernate. And jOOQ works in a way that it puts a little bit more effort on the build time. So when you build your project, it introspects the database and then generates Java classes for you. And these Java classes reflect exactly what you have in the database, so that later on when you build a query, you can just use it just like importing normal Java classes. And the benefit is that whenever your database structure changes, and it changes in a way that is incorrect to the methods you implemented, it will fail during the compilation time. If we look at the simplest one, SQL query, this is how it looks like when you use jOOQ. So it comes with a DSL that looks very familiar for SQL developers as well as Java developers. All these order item and order ID, this is all from these generated classes. But it's always easy on trivial examples. Let's see how it looks like on this more complex one. So we are back to the searching for the properties. This is the way when we concatenate strings manually. This is how we do it with jOOQ. The select part is here at the bottom, like when we select, we can specify the conditions. But first, it gives us type safety, but also we do it all at once. So instead of splitting like before, that first we have to build a query, then we have to bind the parameters, instead with jOOQ, whenever we specify the query, we set already what are the values, and jOOQ under the hood does all that we expect to happen. If you would like to start with jOOQ, it's of course like the first thing to do is to go to its main page. Josh Long recorded a couple of videos in the Spring Tips series about the jOOQ, and there is also one fantastic representation from Michael Simmons from Spring I/O 2017, where he shows how it looks like, how they use it in their project. And jOOQ is really well integrated with Spring Boot, so you can also choose the jOOQ starter on the start.spring.io page. So we talked about the JPA that is, let's say, Java-centric, and the jOOQ that is SQL-centric. Now there will be something in the middle. So there is a new framework from Spring Data JDBC. And it's the version 1.0 was released October last year. And it started with this idea that people want to interact with relational databases, but they don't want to use JPA. Maybe because, that's already my assumption, because of the JPA complexity. And because of all the features that JPA has that maybe people don't necessarily need. So the Spring Data JDBC comes with a simple ORM, and it embraces domain-driven design. It's built from the ground up, so there is no JPA. It doesn't implement JPA. There is no Hibernate under the hood. Of course, what we find out under the hood is the JDBC. And since it's a Spring Data project, it follows the same principles. So there is a repository, there are mapping classes, and there are also templates. And if you use it, it feels actually, at least for me, it feels more like interacting with maybe MongoDB. Like that's like the same level of simplicity that I found in Spring Data MongoDB is the same with Spring Data JDBC. It's just very, very predictable. It has been developed mainly by Jens Schauder from the Spring Data team. And now let's have a look how the example that I showed before with JPA would look like with Spring Data JDBC. On the left-hand side, we have the same code that we've seen before. On the right-hand side, it's the same, but mapped with Spring Data JDBC. So the first thing to note is that it uses different set of annotations, and there are much fewer of them. So the ID that you see on the right-hand side is not the same ID as from Java X persistence. It also drives your design. So if you look closer, the order item does not refer to the product entity anymore. I mean, it does refer, but only by ID, not really by the type as it is in the JPA. And this is because order and order item, this is a different aggregate than product. Product, they are according to domain-driven design. These are two separate aggregates. And according to domain-driven design, aggregates should not reference each other by the type, but rather by ID. And since Spring Data JDBC embraces domain-driven design, it's just not possible to do it with a product. If you would put product over here, you would get like totally unexpected results, and it wouldn't make any sense at all. And now you may say that you could do the same with JPA, right? So nothing stops us from using a product ID over here on the JPA side. And this is true, but the problem with JPA is that it doesn't enforce it. So even if you come up with a very nice design, you structure your entities according to all the, let's say, domain-driven design recommendations, it's still, it's very likely that at one point someone new comes to the project that doesn't understand these design constraints. Maybe you will leave the project, and the whole architecture around how the entities are structured is gone, and you end up again in a mess. The database schema that is expected for this kind of mapping is like automatically reasonable. So Spring Data JDBC is also quite opinionated about the schema. This is exactly what it, you can change the column names, like do the very basic stuff, but it's not the framework that it's meant to cover whatever database structure you have. It's rather, this is how we do it, this is how we should do it. So if you're working with a legacy project and you would like to start using JDBC, Spring Data JDBC for this project, this may not end up well. But if you are starting something new, that's probably something you may consider. How to use it? I mean, the usage is very, very similar. So you also have a repositories. When you need to add a new method, you just add a new method with a couple of exceptions. So one thing is that Spring Data JDBC goes, at least until now, or at least 1.10 milestone 3, because yesterday was milestone 4 release that I didn't check. It implements the CRUD repository, meaning you get all the basic find, save, delete methods, but it doesn't implement paging and sorting repository. So pagination is not, let's say, trivial as it is with other Spring Data projects. Also, it doesn't support derived queries. Derived query is a query that you don't have to write, but it's rather like derived from the method name. So with the Spring Data JPA, this method would work perfectly fine, find by status. In case of Spring Data JDBC, we have to explicitly write what is the SQL query we expect to be executed. I don't actually think that this is a big deal. Maybe it's even better, it makes things more explicit. And of course, it works with a traditional Spring transaction management. There is only one thing that is different. If this code would be written with Spring Data JPA, I mean this confirm method, the save method will not be really needed, right? Because whenever we load an entity from the repository, this is a managed entity by JPA, so JPA and Hibernate, they track the changes that happen in the state, and whenever the method is over, the transaction is over, the changes are flushed to the database. In case of Spring Data JDBC, it's aimed to be transparent, simple. So it will not do stuff that you don't expect it to do. If you don't execute the save method, the saving will not happen. This is this point where I feel like it's more closer to Spring Data MongoDB than actually to the JPA. Which is, again, it's not good or bad, it's just a feature to consider, and I personally like it a lot. It also implements all the goodies about the domain events that are mentioned before. So now the question is, what is missing? And there are quite a lot of things missing if you want to compare it with Hibernate. So there's no dirty tracking, no lazy loading, and this is actually by design. There is no caching, so there is no session cache, there is no second level cache. If you want to do caching, you have to use the Spring application level caching, which again is not actually bad, right? Maybe it's even better. And there are no many-to-one and many-to-many relations because they just don't fit into domain-driven design concepts. But what you get instead is it's simple, predictable, embraces SQL, and enforces good design. And these are good enough reasons to at least consider it. What is like a side effect of it, that since aggregates can reference each other only by ID, it means that also nothing stops you from storing different aggregates in different data sources. It often may make sense to store part of your application in the relational database, but the other part, for example, in Redis. When you reference the entities only through IDs, then you have this flexibility. And we spoke right now about these three frameworks, and all of them have two things or one thing in common. They are all based on JDBC, and they are all blocking, which is not necessarily an issue, but it's just a fact. We now are in the stage where we talk a lot about the reactive frameworks, Spring Web Flux, and of course the blocking connection on the JDBC level does not fit very well. We can work around it with having thread pools, but still, I mean, we use the reactive to avoid having using multiple threads, and then we end up with a thread pool. Doesn't fit very well. And this is where we come to the point where what R2DBC comes. And Ben Hale already said most of the stuff I wanted to say at the keynote. And he also gives a talk today at 5 that I would strongly encourage you to come if you are a little bit in this topic. But what is R2DBC? R2DBC is the spec and also a library that lives more or less on the same level as JDBC, but just for the reactive, let's say, side of Spring. Or not only Spring, because it's not bound to Spring in any way. And this gives us, I mean, other than reactivity, for me, the very important point is that there is just non-blocking. So whenever we fetch the data from the database, instead of getting the data immediately, we get this mono or flux. And R2DBC is split into multiple types of APIs, unlike JDBC. So they basically took the lessons learned from JDBC, that maybe JDBC API is not necessarily like the API you would like to use in your project, but maybe it's good for the library providers, right? So maybe you want this low-level stuff if you build a framework on the top of JDBC, R2DBC. So with R2DBC, we have this SPI that it's meant to be used by framework providers. Like if you want to build a framework on the top of R2DBC, you get this low-level stuff that I personally like. Again, I wouldn't like to see it in my production code base, right? But having this low-level components and functions makes a lot of sense when you want to build the next ORM on the top of R2DBC. They also come with R2DBC client that already takes us one level up. So now, let's say if you want to execute something in transaction, you can use R2DBC in transaction, and the code feels much more natural to normal application developers. And there are, of course, also other frameworks that are built on the top of it. One is Spring Data R2DBC, which again like elevates it one level up to make this code even nicer. And also something that we are totally used to, meaning you can build a repository, extend the reactive CRUD repository, and have the same stuff as you would normally expect. This is alpha stage, so I think it's not yet recommended to use in production, but I mean, who never used alpha stage projects? I know, 5 minutes, okay, I'm faster. Okay, and just come to Ben Hale's talk at 5. And the last thing that I would like to talk is, and how can we test it? So historically, we had lots of issues with writing integration tests for relational databases code, right? So we use this in-memory databases as a replacement, and it kind of works, but it's never the same. Like we use some of the abilities of the real databases, so you either don't use them or you just don't test them. And there is a framework that helps us to actually test the database-related code properly. And this framework is called test containers. It's not only for testing database, it's in general used to spin up whatever Docker container you want from your Java code. And I will show only a subset of it, of how to use it with relational databases. So you add a dependency to test containers. In my case, it's Postgres. Then you just put a different properties to your Spring Boot configuration, and this part is especially important, that you prefix this JDBC TC Postgres SQL, and it works in a way that when an application starts, the container database driver pulls the Docker image, starts it under the hood, and your application is free to use the real database, like, I mean, almost transparently, right? So then you can just write a normal code, like the code that you are used to. You also have to opt out for replacing the test database with the Spring test support. So the key takeaways from this talk that I would like you to remember. There is a world beyond the JPA, and there is nothing also wrong about the JPA. JPA is a fantastic framework. There's the most feature-rich framework, I think, on the planet to interact with to do object relational mapping, but it's not a silver bullet. There are other options as well. Embrace the SQL whenever you need to do something more complex with the databases. I mean, you use the SQL databases. It's silly to not use the power of it. Consider Spring Data JDBC to your project. It's still early stage. It's still a little bit buggy. The version 1.1 is much more promising. It's actually, that's the version that I like to use, but it's still in the milestone 4 right now. But if you are going to like build a new microservice, let's say, this is something worth considering. Watch R2DBC progress if you are considering maybe going into reactive applications. And that's something that definitely use test containers only if you can. If your build server supports spinning up Docker containers, use test containers. It will solve lots of your test-related issues. Thank you very much. These are all the links that you can find the stuff about me. I tweet quite a lot, sometimes too much, and then I have to delete them. And this presentation will be posted soon on the speaker deck that I will also tweet about. So yeah, so thank you all for coming. It was really a pleasure to speak with you, to speak to you. Thank you. And I will be around like for questions and so on.